Hi guys, I hope you are enjoying your online learning day at home or wherever you are. This is just a quick video about multiplying radicals. And a lot of it you already know. I'm just going to reframe some of the things that you know. There's two key ideas whenever we start operating with radicals that you need to remember. The first key idea is that radicals act like variables. So if seeing that radical symbol throws you off, just imagine it's an X instead and see if that kind of helps you frame what you're learning. The key idea we're going to be focusing on today is the product rule of radicals. The product rule of radicals says that if I have two factors being multiplied together inside one radical, I can break them up and put them into their own radicals. And we've been using this idea in order to simplify radicals. So for instance, if I found the square root of 24, I could break that up into the square root of 4 and the square root of 6. Now I can break those into their own houses, the square root of 4 times the square root of 6. And I can note that the square root of 4 really has its own name, and it's 2. So we've been using this topic, but now what we're going to do is we're going to go the opposite direction. The other aspect about the product rule of radicals is that if you have two factors that are in their own radicals that are being multiplied, you can multiply them together under the same radical, so under the same roof, okay? So for instance, if I've got the square root of 9 times the square root of 10, I can multiply those together under the same radical and call that the square root of 90 instead. There's a couple of applications of where we might do this. We might want to do this when we're finding area of a rectangle, for instance, and we're multiplying length times width. Also, it allows us to multiply numbers that are irrational to see if maybe there is a rational number that can come out of it. So an example here is 3 times the square root of 3 times the square root of 12. There's two different notations you might see. This one on the left and this one on the right. They're identical problems, they're just notated slightly differently. Okay, so when we are multiplying radicals, the coefficients talk to coefficients, the radicals talk to radicals. So this 3 is going to get multiplied to the coefficient to the other term. Now you might notice there's nothing in front of 12, but there is, it's just invisible. It's a1. So coefficients talk to coefficients, radicals talk to radicals. I'm going to be multiplying 3 times 1. And separately, I'm going to be multiplying the square root of 3 times the square root of 12. If you multiply your coefficients, coefficient times coefficient, your answer will also be a coefficient. So 3 times 1 is a coefficient of 3. Now, square root of 3 is irrational. Square root of 12 is irrational. But what happens if you multiply those two together under the same radical symbol? You might notice that you get a perfect square. In that perfect square, square root of 36 can be simplified to just say 6. So now our answer is 3 times 6 and can be evaluated to say 18. And that is your final answer. I'm going to go over that real quick. First, what we did was we kind of noticed what's a coefficient and what's a radical. We multiplied coefficients to coefficients. We multiplied radicals to radicals and put them under the same radical symbol. Then, under the same radical symbol, this one right here, we said, hey, is there anything we can simplify? If so, go ahead and do it. And so when we simplified, we saw that square root of 36 was a perfect square. It's just 6. And so our final answer is 3 times 6, or 18. Okay, same kind of problem. Now we've got a coefficient talking to a coefficient, and we've got a radical talking to a radical. Okay, this is the same thing as if I said like 4x times 2y. I would still multiply my coefficients together, right? And then multiply my variables after that. Same kind of thing. So let's start by multiplying my coefficients. I get 4 times 2, which is 8. The product rule says I can multiply my radicals if they're being multiplied together under the same radical symbol. So I'm going to take that and I'm going to simplify it to say 8 times the square root of 24. Now, I need to simplify this. The square root of 24 is not simplified. So now we're going back to the very first thing we did in this unit, just simplifying a radical. So I'm going to call this 8 times the square root, and I'm going to call this 4 times 6, because that 4 is a perfect square. So I'm going to call this 4 times 6 now, so that I can simplify this 4 to call it 2. So now we've got 8 times 2 times the square root of 6, which simplifies fully to be 16 times the square root of 6. So again, this is the same process as before. Step 1 is to multiply your coefficients together. Step 2 is to put your factors of your radicals under the same symbol. I'm going to say rad symbol. Step 3 is to simplify all the things. So simplify your coefficients and simplify your radical as far as possible. Far as possible. My handwriting looks horrible. I'm so sorry. Okay, and that's how you multiply radicals.